So in the directional felling system, we use an open face notch 70 to 90 degrees. And the reason that we do such is that as that tree is falling, it gives us the ability to let that tree fall all the way to the ground before that notch closes. And a lot of times the tree is still attached to the stump via the hinge. If you use anything less than that 70-degree angle and notch, as that tree falls, that notch closes. When that notch closes, it tears and breaks the hinge loose from the stump, and it goes in the direction that it wants to go. That open face notch allows that tree to continue falling all the way to the ground, where a common notch or a 45-degree notch, it snaps, it breaks way before that tree is on the ground, and it can allow it to then fall in the path that it has the most amount of lean or weight, which most likely is away from your intended direction of fall or your path of least resistance, causing damage to your residual stand, or creating much more work for yourself by losing that tree because the knot's closed before you needed it to. So West Coast, they use a Humboldt notch, and it works for them because they're cutting primarily a conifer tree. They typically are cutting it higher off the ground, and they're not getting any regeneration. Whereas we're cutting hardwood trees, we're cutting them as close to the ground as we possibly can so we can give that stump sprout, root sprout, a better foundation to start from, as opposed to having this really tall stump that's going to rot away and then the regeneration would fall away from it. So I'm going to demonstrate how to make an open face notch with you. So we'll talk about it real quickly, and then we'll actually go through the process and do it. So if you look at our chainsaw, we've got two positions in our handle. And I like to stick my pointer finger in that bend for my down cut, and then I like to get buried as far into this bottom corner here as I can for my up cut in order to make my two cuts that would make my notch, and that allows the two angles that are built into the handle to come together in order to make that 90-degree open face notch, and a lot simpler when you do that. So when I'm making the down cut of that notch, I'm actually using this line on the top of my saw. It's the sight line, and I am aiming the tree directionally to get it to fall where I want it when I'm cutting that notch. Okay? So we'll go through the starting procedure, put all your protective equipment on and in place prior to picking the saw up, activate your chain brake using your leg lock method of start. Okay, so there's our notch that come out. And we're shooting for 70 to 90 degrees. I think that we got that really good, pretty close. So the two cuts, we have a down cut and then we have an upward cut. When I'm making this down cut, I'm aiming again with that top line on the saw. When I'm making this bottom cut, I'm looking down inside of this saw curve as I bring that saw to that point so that I can see that I don't have any bypass in that notch. Because if I have bypass in my notch, as that tree starts to fall, that bypass will close first. When it does, it's going to cause hinge failure, and the tree's not going to go anywhere close to where you were aiming it or had it desired to go. So the next step would be to make a bore cut so that we can establish our hinge behind this point of our notch so that this tree has the ability to pivot on that strip of wood as it's falling. And hinge length and width are all dependent on diameter, and hinge length would be from this outside corner to this outside corner, giving us about 80% of the diameter of the tree in length, and then our thickness will be maximum 10% of the diameter. Otherwise, anything more than that, and we run risk of barbaturing or splitting the tree when we are felling it. So we'll go ahead and do a bore cut now. So we've made our notch, we've made our bore cut, we made our release cut out the back. And in order to demonstrate how this notch functions, we've had to really thin the hinge out so that I can get this block of wood to move. But you can watch the notch close as this block moves in the felling path. And as it keeps continuing down, the notch still hasn't closed. There it's closed. The tree's almost horizontal with the ground. And at that point, the hinge would break and it would fall on off. Okay? But that's the dynamics of how the hinge works, what it does for us in the felling process, so that we can effectively get trees to go where we want them to go as opposed to where they want to go. And that's the skill, that's the practice, that's what we strive to do. So we're in the wood pile today. These are some trees that had to be removed for hazardous reasons. They were dead and in a park setting. So they've been removed and they're laying here being processed for firewood. But you can see where the notch was cut here. And this strip of wood is the hinge that we were talking about in the previous video. And you can see some of the fiber here that is a little bit long as opposed to what is up in the front. So the thickness of the hinge, the distance from the point to the inside edge, is based on the diameter. And the maximum thickness is 10% of the diameter of the tree at breast height. And then we need 80% of the diameter from corner to corner for our length. But this may have been a little too thick. It should have been thinned out maybe a quarter inch or more so that these fibers shorten up. So what happened as this tree was falling is that these fibers had to tear out of the stump in order to allow the fiber in front of it to start to bend to create the hinging effect that we so desired to have happen. And every stump tells a story. Looking at this, you can see some half moon shapes. We can see where it was bore cut from that direction, and then it was bore cut from the other direction. I don't see, maybe, I do see some area here where there were some wedges put in it where it was driven over, picked up, so it could be wedged over. But the importance here is that it has a hinge and its full length and thickness to hold that tree to get it to go where you want it to go.